Good morning, one and all. My name is Sudhir Chandra. Today, I'm going to discuss a new topic, which is currently a booming industry, and everyone know, uh, like ChatGPT and many other tools. So the main technology behind any such models, whatever the language models we have seen in the market, such as ChatGPT, or we have many AI tools. All of them are having the fundamental basic language models. So what basically this language model means and how they are going to work. So we can understand the basic technology behind it. So before diving into the topic, I would like to have a discussion on how these machines are going to work. Machines, how they're going to land the things in the data. When I say the machine learning or data science or AI, the main important thing is the data. So data is plays a crucial role in all of these domains. So here on the screen, we have an example uh, on a plot where it gives uh, two different insights, such as the length and chest size of a gorilla animal. So have been plotted the graph between the length and chest of the gorilla animal. Now, can you see that these are the different animals, the different length and chest size. Now, what I'm trying to do is, if I randomly pick some animal and I measure the length of that animal, and I would like to get the chest of that particular animal. So how I can do that? It's simple. So let's draw some line like this. Okay, let's draw some line like this. It's a straight line. That means you're going to fit the straight line to this entire data. Okay. So now if I randomly pick some x value, let's say x equal to 72. So some randomly I have taken the value of x equal to 72. Maybe the 72 is lie down here. Okay. Now if I draw a straight line like this, so it is gonna touch the my line here. So the corresponding y value will give me the chest size of the particular length. So this is a simple technique, right? We have the data. Now we need to find this line such that we can get the chest size. But only these, how many such lines are possible here? We can draw infinite lines, right? This is one line and this is one line, or we can draw like this one more line. But we need to draw a line such that which is more efficient, right? So how we can find the more efficient line that which can perfectly suit to this entire data. So here the concept behind is very simple. What is the equation of the line? Y equal to mx plus c, right? So this is the equation of the line, a linear equation. So what is the m specifies? M specifies the slope of the line and c specifies the intercept made by the line with the y-axis. So now let's consider this equation. My x is nothing but the length and y is nothing but the chest size. And now let's consider this is one of the straight line I'm hitting this line. Is the straight line is it feasible? Whether it is the most feasible line? No, right? Because if you fit like this, these points are very far from this line, right? So now what I'm trying to do is I'm just trying to move the line towards the data points. Is this a good fit? No, somewhat better. We can move, right? Yeah, like this, like this. So now this is a good fit, right? This is a good fit. So if you try to find a line which is being a good to the model, then you will get a good result. Okay. So now I'm trying to fit a linear equation to this data points. Why only linear? Don't we try to put a curved line like this? It is more suitable. Okay. Curve is a good thing, right? It can able to reduce the more. It can able to give the more insights of the data rather than the linear equation. So the question is which to fit? whether we need to fit the line or we need to fit the curve. Let's dive more. Let's look at the more of the things. If I'm trying to find the best fit, what is the best fit? Then which line is the best fit line? So the best fit line is, it's very simple. You take a line and you find the difference between the actual value and the predicted value. What is the actual value? Actual value is this point, and my predicted value is this point. You take the difference of these two. So whatever the points lying on this line are my predicted values. So I need to try to reduce the error such that the line will be the perfect fit, or we can say the best fit line. So not to find the optimal values of M and C in the equation such that we have the minimum error. Now I need to find such a line with M slope and C as my intercept such that I should need to have the minimum error. So how we achieve this? So there is a concept called gradient descent algorithm or gradient descent technique. So we are going to update the M value and C value according to the gradients we calculate. So in the previous example, we have seen the line is at very narrow position. Then we are just increasing the slope, right? We are just increasing the slope. So that means we are trying to move the line or increasing the slope, or sometimes we can decrease the slope according to the rule, such that we need to minimize the error. Okay, so this is the logic behind fitting a line to any data. But how? But how I can relate it to my language models? It's very simple. Take the insight what we have learned so far. We have the data. We're trying to fit the line. But in a language task, we don't have any numerical data. Everything in the form of a text. But now what we need to convert that entire language into a textual data. So let's have a small example of sentiment analysis. So we have a lot of feedbacks that we are getting in a YouTube or in any other platform. From the user, we are going to get a lot of feedbacks. Now we need to identify whether it is a positive feedback or negative feedback. So suddenly, if you are having lots of data and you need to convert the entire data into some numerical form, and now we need to give it to the model. So my model can understand the tweets. So suddenly a new tweet comes. So it can analyze the tweet and it able to give the answer whether it is a positive feedback or negative feedback. Okay, let's look at a small example. Okay, so let's take a tweet here. So a tweet have two things, right? Either it is a positive or it can be a negative. And consider positive as a value 1, negative as a value 0. Okay, machines cannot understand the language, so we need to convert them into numerical form. So that's why I'm giving the 1 and 0. And now see, now what I'm doing is, I'm gonna be taking every comment, I'm just splitting every comment into each individual ones. Let's suppose we have an example of, because I am happy because I'm learning the NLP. I'm happy. I am sad. I'm not learning NLP. These are my 4 different data I'm having. Now what I'm doing is, so this is a positive feedback, so I'm giving the value as 1. This is also value 1. This is, I'm sad, it's a negative feedback, I'm giving a value as 0. And this also I'm giving 0. Now what I'm doing is, I'm trying to take the entire feedbacks and I'm trying to find vocabulary. What is vocabulary? Is set of the unique words present in my feedback. So if I take the every word, I am happy and everything, I'm trying to find the unique words among them and I'm trying to make the vocabulary. And now here, we am trying to calculate the frequency of positive and frequency of negative. That's how I'm trying to do. So here, I'm having I. Now, I appeared how many times in positive feedback and how many times it appeared in the negative feedback. So let explain me one example of I so you can understand. I repeated 3 times in positive feedbacks. These two are the positive feedbacks. And it repeated 3 times in negative feedback. So this is 1, 2, and 3. Likewise, you need to compute the every individual vocabulary, how many times it repeated in the positive and how many times it repeated in the negative feedback. Okay. Now, the next step is So the now next step is how we are trying to give a data point. So previous in the example, we have a data point, right? So one is a length and one is a chest size. So we have the X value and we have a Y value. But now what is my X and what is my Y, right? So now what I'm trying to do is for every vocabulary, okay, for every vocabulary, what I'm trying to do is I'm just taking the frequency of that word, particular word, entire sum I'm going to take. So what that actually mean? Suppose if I have taken a word, I am happy because I am learning NLP. Okay, right? Now here I need to transform this entire sentence into a numerical form. So for that, what I'm taking is I'm taking how many are positive feedbacks are how many of these vocabulary. First, you need to find the what are the unique vocabulary are present in it, and then which are how much what is the positive frequency and what is the negative frequency. So let give an example. Like suppose if you take the I am sad, I am not learning NLP. Like how many unique words you are having in these I am sad and learning NLP not. So these are the different unique vocabularies that you are having in this sentence. Now, how you can convert this sentence into in this numerical array, numerical form? Just you take the positive and negative from the frequency table. So far we have calculated this frequency table. So from this frequency table, you are just take the values and you need to fill the values here. Now you compute all positive sum and complete negative sum. And you replace that values here. So now we are getting the 8 and 11. So now we are having the positive feedback and you are having the negative feedback. And then you just have converted you need to convert the entire such feedbacks into numerical arrays. Then now we have the entire data, right? The now task is how you can fit a line to it. Okay, let's look into it. Now we are converting, it is nothing but a word to vector. So we are just converting a word to a vector form, right? So I am happy because I'm sad, I'm not learning NLP. This is my word. Now I'm just converting it to a numerical form. That means I'm like converting it into a vector. Now I will convert the entire such things into my vector, right? So this is my first sentence, this is my second sentence, this is my third sentence. Like that, I am going to prepare my data set. So this is 140, 20, 120, 50. This is a positive, this is a negative frequency count. And then what is my output? Okay. In the previous example, the Y is my chest size and my X is my length. Now what I'm doing is my X is having the my X is one, X1 and X2. This entire thing is my X. And the Y is 0 or 1. It is just classification task that we are just taking only two values, whether it is true, whether it is positive or it is negative. Now, now what I am to do, I need to fit a, a line, right? So now I need to fit a line. So in the previous, we have only one variable, X. Now we are having the two variables. That means we are having the positive frequency count and the negative frequency count. So just the equation is look like as this. Y is equal to m1x1 plus m2x plus c. So now what I'm trying to do is I need to find the m1 value, m2 value, and the c value. The same way what we have did so far. That we need to minimize the error. Okay. But now, how does the model look like? Previously, it is a line, right? Now it is a plane, right? So previously we have only one parameter so that we are just trying to fit a line. But now we have the two parameters. We need to fit a plane. You can see in this example, we are trying to fit a plane equation to the my data points. So my x1 and x2 are the positive and negative feedbacks I'm having, and my y value is either it is 0 or it is 1. Okay. So based on that, I'm trying to fit a plane equation to my data. So this is how we are trying to uh, build a language model by converting the entire text what I have given into a numerical form. So like this, the model can able to understand the things clearly and it will give the response. The basic idea behind of sentiment analysis is the same idea what we have so far used for calculating the uh, uh, size of that gorilla's chest size. But the concept is same. The concept is same, but the data set is different. Now it is our main idea that how we can transform the language based text into numerical based text, so such that we can use the concept of the linear regression here. So this is the concept that we are using. It is called as linear regression. So I hope you understand the things clear. So this thank you so much for thank you